Hey guys, this is Mitch with FindPoint CGI, and today we're going to continue the Basics with Godot tutorial series, where I take you through from not knowing anything about Godot all the way up to being pretty decent at Godot. So today we're going to talk about 3D navigation meshes, and we'll probably jump into 2D navigation meshes probably in the next tutorial. But in this case, we're going to focus on 3D navigation inside of Godot. So what I'm going to do is I'm going to take you through the process of building a level, baking the navigation inside of that level, and then setting up a small character that you can click and run around that little level so that way you can see how the navigation system works. But first, we need to talk about what the navigation system is. So the navigation system is Godot's way to calculate your navigation of all the characters in your scene. So what it does is it bakes the path-finding grid almost and tells the system, when you click on one spot, it tells the system the shortest path between those 2 points. It's extremely useful for like grid-based games. It's extremely useful for AI, sentries or something like that. Or if you wanted a point-and-click adventure game, things like that. It's a super useful system for that, for static meshes. Now, where things get a little funky is when you start adding in platforms and things like that. And that's when you want to go for a more verbose navigation engine like A* or something like that. Now, this specific tutorial here is for Godot 3.23. And the reason why I specify 3.23 is because in 3.4, when it comes out, they're coming out with a new, I think it's 4 actually, it's not 3.4. In 4, they're going to be coming out with a new navigation server, which is built upon the A* platform, and it's completely different. So if that's what you're looking for, go ahead and wait. I'm going to make a tutorial on that when it comes out, and then we can go from there. But with that being said, let's go ahead and jump into Godot, and we'll take a look at this. All right, so now that we're in Godot, what we need to do is we need to first create our node. So let's go ahead and add in a other node, not a just regular node. You actually need to add in a other, you need to add in another node. You need to add in a navigation node. Okay. And what that's going to do is that navigation node takes all of the sub nodes under it and uses that to determine navigation. So it's very important that you use that as kind of like your root level node almost. And that's the node that's going to handle a large sum of your navigation calculations and things like that. So next, what you need to do is you need to add in another child node and you need to add in a navigation mesh instance. Now, a navigation mesh instance actually takes the meshes that are under it and it uses that to calculate your navigation nodes, if that makes sense. So what it does is it takes the bounding box almost of the side of the entire project that's underneath this navigation mesh instance, and it creates points so it can determine how it's going to navigate around objects. So we'll place that. I mean, if none of that made any sense, basically it just lets you bake your navigation mesh. I mean, it's really that simple. Then what we're going to do is we're going to right click, we're going to add another child node, we're going to add in a mesh, and we're going to add in a mesh instance. And let's go ahead and add in a new plane mesh like this. We're going to scale this up, something decent in size. Let's say about that big. That works for me. And then you'll notice that if I click on this, it'll have a little tiny node configuration warning. A navigation mesh resource must be set or created for this node to work. So what does that mean? Well, what that means is we need to create a navigation mesh instance here. All right, so now that I have that little navigation mesh, what that is it's basically the thing that your navigation mesh kind of bakes to almost. It's the nav mesh instance that it bakes into. So now what we're gonna do is if we click bake nav mesh, you'll see that I got a lighter color here, see? and you'll see if I kind of hover down, you'll see that it kind of is above right here versus right here. It's kind of above your mesh. And that's how Godot determines things to be navigatable, if that makes sense. So let me show you. If I were to right click, add in another mesh instance, and I were to add in a cube. All right. And then we move that cube like here, let's say, and we click on mesh or navigation mesh and we bake it. You'll see suddenly it shows around that object your collision almost, right? So the game, or I guess Godot, has figured out that, hey, this is not a passable area. You're not able to pass this, so don't, the character's not allowed to pass that. So now what we can do is we can go ahead and duplicate this. So Control D, and then let's go ahead and drag this over, let's say here. Let's drag this down, something like that, okay? And now if we bake this, you'll notice, weirdly enough, it did not create that, right? It kind of did like a little hump and then up and over, right? Now, the reason why that is because of the navigation mesh settings. So if you click this open here, like this, or if you right click and you do edit, it'll allow you to edit it as well. And you can see you have a lot of these options here. So if I open these all up so I can kind of show them all to you, because there's a lot of them. I mean, look at them all. They're crazy, right? So let's go through them one by one, because I know this is a lot, but trust me, once you go through them one by one, it's really simple. So your first parameter here is the sample partition type, okay? And you have watershed. If I click this open, if you have watershed, monotone, and layers. Now, what these are algorithms, and they're used for graph traversal algorithms. There's a whole lot of information there, but basically what it does is it computes points in your navigation mesh. So watershed is basically, it uses the highest point, kind of like a watershed, in order to make paths for the navigation mesh. So you can see here how it makes a point here. See, point and another point to kind of create this navigation. Whereas if you did monotone or layers, you'll notice that suddenly this actually works properly, right? So if I change it over to monotone, what it does is it sorts the points in the navigation mesh so it can build a path. So you can see here how it suddenly got it correct. So what it does is it actually uses the underlying mesh to create the navigation points. And layers allows you to bake from almost like layers. It kind of just bakes it up, going up until it hits the height that it's allowed, if that makes sense. So this is a fairly accurate way to do it. What I suggest is instead of running through, just run through them and see which one bakes the best navigation mesh for you, because they're all just different algorithms on how they handle the navigation system, if that makes sense. All right, so now we have geometry here. So if I change this to monotone and then we take a look at our parsed geometry, you can see that there's mesh instances, static colliders, or both. Now, mesh instances means that it's going to bake off of the mesh instances. So off of these little mesh instances here. Static colliders will only bake off of colliders that are static, or both. And both means it's going to take both mesh instances and static colliders and then use those together as a way for it to create your navigation mesh. Now, generally speaking, I like to use mesh instances. However, if I'm using custom level geometry that has a lot of data, static colliders makes more sense. It's faster for the algorithm. So you're going to want to use static colliders if you're using a lot of custom geometry and stuff like that. Because if you think about it, if your floor is, 100,000 polygons, right? Well, your static collider might only be, 50 polygons. And that will help build a proper navigation mesh, versus using mesh instances, which would really bog down your bake time, if that makes sense. Source geometry is how it determines what is considered a navigatable mesh. So if you were to say nav mesh children, it's any child that's underneath this navigation mesh instance. Group with children is if you were to specify a group. So you'll see here that there is a group name. So if I were to take this object here, this mesh instance, and I were to add it into a group. So if I come over here into node and then I click groups and I create nav mesh, and let me copy that real quick, and I add this to this group, and then I select this object and I also add it to that group. And then if I go back to the nav mesh instance and I change this to nav mesh, when I bake my nav mesh, you'll notice that this no longer got affected. So you can see here, if I can select it, that'd be great. There we go. You'll see that this did not get affected, right? If I add it to that group, paste, add, and then I rebake my nav mesh, you'll notice that suddenly that nav mesh is now calculated once again. So it's really useful if you have lots of objects underneath a nav mesh. You know, for instance, your entire project's underneath this nav mesh and you want to exclude or include stuff. Using a group would be really useful for that. Group explicit will only apply the group. So for instance, if I were to select this object and I create a child node and I do mesh instance and I change it to a cylinder, let's say. So now I got the cylinder sitting here, providing that I can find it. There it goes. That's a big cylinder. So let me make it a little on the smaller side. There we go. So now I made it a little smaller and we'll put it into the ground. If I were to put, now you can see this object does not have a group. You see how it doesn't have this little icon, so it's not in the group. And if I go over to the node, you can see it's not in the group. But if I go to the navigation mesh instance and I go back to my inspector and I go group with children, when I bake it, you'll notice that it calculates that, right? It calculates the nav mesh around it. If I go with group explicit and I click bake nav mesh, you'll notice that now it's not affecting it because this object is not a part of that group, right? It doesn't matter if it's a child. If you have group explicit, it doesn't care. It just says whatever is in the group is a navigatable mesh. So you can see how these are navigatable. See? So that's how you can tell the difference between those. Cell size is almost like the resolution of your mesh. So if you were to bring this down and you were to bake it, you'll notice that, see how these are a little bit more divided. So if I were to bring this down a bit more and bake it, well, I guess in this case, it's not going to show. But if I were to bring it up higher, you'll see how those points got, those bevels got removed. And the reason why is the cell size determines the resolution of this mesh. So you'll have to tweak this a lot to determine how much of, to make sure that all of your nav mesh actually makes sense, right? Because, if you have two objects close to each other, your cell size may need to be smaller so it can determine that there is space enough to walk between those two objects. Height is exactly what you would expect it to be. It's the height at which this simulation or this little nav mesh can be baked. So if I were to bring this down to something like 0.1, when I bake it, I guess in this case it didn't do anything, but if I turn it up higher and then I bake it, you'll see that the actual mesh itself has gone up. See? And I bake it, you'll see that it comes down. So this is useful if you want to offset the height of objects from the ground. Agent height is the actual height of the agent. So if you have an object for this thing to traverse underneath, right, the agent height matters. So if you were to take the max climb down, you'll notice suddenly it cannot climb on top of this because it is below the max climb threshold. If I were to put that up higher, you can see now it can. If I were to put that up really high, you'll see that now they can climb on top of this because the max climb height is high enough that they can climb on top of this. See? So if I reset that to 0.9, radius is the radius of the navigation agent. So if I were to bring this next to this and I were to, let's change my navigation mesh from that to nav mesh children, and we'll just bake this. You'll see that it creates a separation here. But if I pull this out a little bit further and I bake this, you'll see that it allowed you to walk through these two objects. But if you were to change your radius up, now you can no longer walk between those. So radius is the radius of the character itself to determine if it can walk between two objects, if that makes sense. So you can see if I bring that down, now you can walk between these two objects. Max slope is the maximum slope that you can walk up. So if I were to take this object and duplicate it, let's say, let's move, well, if I grab the right thing, let's move this over and let's scale this down and rotate it, something like this, right? And then we bake this. You can see that he can't walk up this. But if I were to change this to 90, you can see now he can, the character can walk up this slope. Now, I would need to mess with the cell size and the height and things like that to get a good navigation mesh. But you can see that because I changed the maximum slope, that's the maximum slope that the character can walk up. Now in this case, you know, something like 80 or 70 would probably work, but generally speaking, the default is 45 degrees. But you can see how they can't walk up this. It's not 45 degrees, right? So if I were to change this to something more, you know, 45 degree E, and I were to bake it, now the character can now walk up this slope. So that's the majority of what you have with the agent. Again, to kind of recap, height is the height of the agent. Radius is the width of I guess what is around the agent. So what it can fit through in terms of gaps. Max climb is the maximum height that the navigation mesh is allowing the person to go up. And max slope is the maximum slope or the angle that the character can walk up. All right, so the next section is region. You have a minimum size and a merge size. So if I were to bake this nav mesh, you can see that everything seems like it's being baked, right? But if I come over here, let's add in a new navigation mesh instance, and let's make it a plain mesh. I don't know where, I put it over here. So let's drag this out over here, off by itself, and let's kind of focus in on that real quick. So what region and merge size is it determines if it gets baked on a nav mesh. So you can see here how this is being baked. But if I change the minimum size up, something like 73, now this is no longer being baked. And it's the same thing over here. You can see that the cube no longer has a bake either. You can see, if I bring this down, how now the cube has something on top of it. So what this does is it determines the minimum size that is considered a walkable surface inside of Godot. Now the merge size is the same thing, except for it determines the size at which it can merge into other meshes. So if I were to make this a really high number, in theory, things will start merging into each other. So if I reduce this down to a very small number, you can see that merge did not happen. It's a way for the nav mesh to merge and simplify itself, if that makes sense. They look kind of like a decimation modifier inside a Blender, right? It pulls the vertices together and combines them. So this is really useful for optimizing your nav mesh, but it can also create problems inside of your nav mesh, such as this, right? So the character can no longer walk directly through there. They're going to walk up and then over. You can see, if you look at it, they're going to walk up here, and then over it, and then down. See? So let's go ahead and rebake that, and there we go. Edge is very much similar to region. You can actually determine the maximum length of an edge. So if the edge is let's rechange that. So if I put this down, you'll notice that when I bake it, there are a lot more edge lengths here. See how how it changed it, how there's now a lot more edges, a lot more things like that. It's the maximum length that can be determined if it's a good edge. So you can see here, if I bake this up, how it simplifies the mesh. But if I pull this down to something like 0.1, right, you'll notice that things start changing. Well, sometimes it changes, sometimes it doesn't. You got to find like the special sweet spot to get this thing to actually do it. But what it does, it's the length of an edge that can be determined if it's valid, if that makes sense. Max error is the maximum error threshold of a mesh. And again, you're not going to see much difference inside of here. But if I bring it down, you can see that this changed, how it almost follows the edges closer, if that makes sense. Now, generally speaking, you kind of want them to be smooth, right? You don't want your characters to be like bouncing around or anything like that. So just make sure that, you kind of use it to help smooth out your edges, if that makes sense. Verts per poly determines the number of vertices that can be considered a polygon. So if you were to bake this, you can see that we have 6, right? And there's, again, you're not going to see much of a difference here as I kind of move it up and I move it down. But generally speaking, what it's useful for is it's useful for optimizing your navigation mesh. So I'm going to keep that at the default 6 because, to be honest with you, I don't really ever touch this whenever I use it for navigation mesh. So I wouldn't really worry about it too much. Sample distance for detail meshes. So if you were to put that at 0, you'll see suddenly, well, everything slows down like crazy. And the reason why, and it'll probably crash my computer because I probably shouldn't have set it to 0, but the reason why is because now this is how detailed your navigation mesh is gonna be. All right, so Godot has crashed for me. So I actually just rebuilt my scene. It's not quite the same as what you guys saw, but at least we can continue. So detail is the detail of I guess you could say the resolution, or how its second pass happens. So if you set this down to something low, it may or may not crash your computer. So make sure that crash your project. So make sure that you're careful. But you can see here, like how it affects right here, right? So you can see this, and then if I pull this down to something like 1, you'll see that how it changed it. See how it's slightly different. It seems to fit better, if that makes sense. So what we're gonna do, I'm gonna bake that down a tiny bit. There we go. And now, finally, what we have is the sample max error, which is the amount of errors that it can have before it says, hey, this is not a good enough mesh to move on, if that makes sense. So you adjust that to kind of help refine this. So if we kind of bring that down, you can see it kind of changes it slightly. But if we bring it up, it kind of changes it a bit more. And you can also see how it can affect, see that? How it can affect this. So you can see when I bake it, how it has a problem there. But if I pull this down, you can see that it snapped that up. So that's kind of what the sample max error is. Now, generally speaking, I don't mess with this. I generally just mess with the agent height and the radius and the max climb. And that usually helps me out. So you can see when you change those things, how it can change how your objects can walk along these things. So you can see because of the height, they can't walk underneath this anymore. Whereas if I reduce the height, like I've shown you before, now they can. Or if I change the max climb down, you'll see that they can no longer climb on any of these objects. If I bring it up a tiny bit and I bake it, you'll see that now you can walk along this area because now they can climb up here. Obviously, we don't want that, so we're going to bring that down a tiny bit. There we go. So now they can't walk along that. But we do want them to have the ability to go through here. So let's bring the radius down some. And bam, now we can walk through here. Perfect. There we are. So now if that's the case, let's look at filters. Now filters, I'm not going to show you how they work because getting them to work is an absolute nightmare. But generally speaking, low-hanging obstacles allows you to have low-hanging obstacles inside of your project, and it filters those out so it doesn't affect the navigation mesh. Ledge spans basically just spans over ledges. So if there's two ledges that are next to each other, it can span between the two. And filter walkable low height means it's going to filter out any walkable lower height issues. So for instance, this is too close or it's within a specific margin, this will filter those out. All right. Now we get to come to the fun part, coding. So what we're going to do first is we're going to create our character and get that started. So let's first right click on our navigation, add, and type in remove that, open up spatial. Let's take a look. We want a position 3D, so let's grab that and let's just call this player. And then let's go ahead and add in a child node and add in a mesh instance. And we're going to make this a capsule mesh. So now let's rotate this 90 degrees. If you hit Control and rotate, it will snap it. And then we will scale this down some. So let's make it smaller. I'll see I need to change this to be not local transform. All right, let's drag this over here real quick. Oh, and actually I need to grab my player. Oh dear, let's get rid of all of this. Let's start it over real quick. And what we'll do is we will first scale this down like this, and we will scale this down like this, something simple. And we're gonna rotate this 90 degrees. And that should be good. We're gonna drag this up. So now it's a player walking around the world. And you can see that this is now at the base of the capsule. Now that's important because if it's not at the base, then the player's not gonna be able to walk around on this navigation mesh without having some kind of difficulty, if that makes sense. So now what we're gonna do is we're gonna add in a camera because you need to have a camera for it to work. So we'll go ahead and add our camera. We're gonna drag this out here and we will place it right here, I think. So let's, oh, whoops. I am the worst when it comes to navigating some of these things in Godot sometimes. Let's rotate this 45 degrees. Let's pull you up. And then let's change this to local and let's snap that down a few. Let's take a look at that and see if that's good. We'll change our FOV to 90 because 90 FOV is good and it'd be nice. And we're gonna say, yes, this is the current one. And quick tip for you guys, if you guys just click preview, you guys can see what it's gonna look like. So I don't mind that. It'd be nice to move that a bit closer. So let's go ahead and move that a touch bit closer. Like that. That's too close. So let's pull that back a tiny bit. There we go. That's good enough for what we're trying to do. So now what we're going to do is we're going to right click on navigation. We're going to attach a script and call it navigation.gd. You could call it whatever you guys want, but I'm just going to use navigation.gd. All right. So the first thing we want to do is we want to have a conversation about what we want to do, right? So what I'm going to do is I'm going to make an object that follows another object. So we're going to make the player follow an object around this navigation mesh. So first, what we're going to do is we're going to add in a mesh node. And we'll say mesh instance, let's say. And let's go ahead and make that a capsule mesh, and let's just make it small. We'll go ahead and just make it tiny, like this. So what we're going to do is we're going to tell the player to walk up to here, I think. There we go. There, that should do it. And then we'll take the player and we will place the player over here somewhere. So the player's not near the navigation mesh, and this will force him to kind of navigate around to find the best path to the player or to that mesh instance. And we'll call this goal. Whoops. All right, let's go back to here. What we're going to do is we're going to say on ready var, whoops, not bar, var player is equal to get node player. Whoops, it needs to be quote. All right, on ready var goal is equal to get node goal. All right, now what we're gonna do is we're gonna go into function ready, and we're gonna say actually we're gonna need a var here, path is equal to open and close, because we're gonna need to create a path for the player to walk along. And then what we need to do is we need to say path is equal to get simple path. Now you got to start, an end, and an optimize. Okay. So first, what we're going to do is we're going to say player dot transform. Actually, to be dot translation. Yeah, dot translation, comma. Now we need to get the target point, so we'll say goal dot translation, and then we will also say true because we want to optimize that point. And now what we need to do is we need to force our movement to happen. So we need to have it in func underscore physics process, because we don't want it to run on the, like, if you remember, I don't know if you guys remember this from previous tutorials, but this is called every frame on your GPU. Physics is calculated on a set time frame. And when you want to move objects, you want to try to move it without it being frame dependent, because then it depends on your frames and how fast your computer can render something. So you want to use it off a physics process anytime you're moving objects. So now the first thing we need to do is we need to say var direction is equal to vector3, and we will say var step underscore size is equal to delta times our speed. So what we're doing is we're saying, hey, and I spelled delta wrong because I can't spell. What we're saying is, hey, we want you to take our physics process time and then multiply it by speed, and that'll be how much to move the character each translation, if that makes sense. And then what we'll say is we'll say var step amount is equal to delta times, that's plus, times 10. And then we're going to say if path.size is greater than 1. Dot size is greater than, 0, I guess. So now we need to determine our direction. So what the direction is kind of like the difference between where we currently are and where we'd like to go. So think of it kind of like you need to make your character look in a general direction to move in that general direction, if that makes sense. So first we need to say var destination is equal to path 0. And that's why you have that little bit of error handling here, is because if we did path 0 and it was a size of 0, we'd get a hard crash. So we probably shouldn't do that. And then we want to say direction is equal to destination minus our player dot translation. All right. Now, once we have that, now we need to step to the next node, if that makes sense. So if we don't do that, there's a possibility that the character could just keep walking, and then it might walk into a wall or, jump off of a cliff or something like that, right? So if our step amount is greater than direction dot length, then we need to do step amount is equal to direction dot length. So that way, what we're doing is we're saying, hey, we don't want you to walk over what our direction expectations would be. So we don't want you to go past our point, if that makes sense. So if you have a goalpost, you don't want the character to run past that goalpost. You want them to run to that goalpost. And then what you want to do is you want to remove PATH, I can't spell today, path.remove 0. So you want to remove that path from the node. Since we are going to be reaching this node, we don't want to constantly be running to the same node. So now that we have that, we want to do player dot translation plus is equal to our direction dot normalized. All right, times, whoops, that's not times, times our step amount. All right, so what does this do? Well, what this does is it moves your player towards that path node, and it moves them by the amount right here that we want them to move. So now that we have this, let's go ahead and test it. So let's try and run this and see what it does. Probably not going to work, but let's find out. See, we've got a hard failure right here because I can't spell. So let's copy that and paste it, save. Let's refresh it. And there you go. See how the character just ran to that point. Fantastic. That's exactly what we wanted. So let's slow that down a little bit so we actually get to see what it's doing. So let's change this size down to something like 2. And now let's try it. So you see he runs through, climbs up, and runs to the location. So now that we have this, we don't necessarily want our player to go to just one goal. Let's have them go to multiple goals. So first thing I'm going to do is I'm going to grab a node and I'm going to make this into a group and just call this goal. Goals, and then we will add that. Now let's take this, duplicate it a few times, and let's pull this down here. And let's grab this one, pull this one down to here, and let's move this one over here, and then let's control duplicate it and move it over here like this. So what that's going to do is it's going to give him multiple goals to be able to run to. And now what we're going to do is first we're going to save so we don't lose our stuff. And then we're going to go back to our script. We're going to say goal, instead of get node, let's do get underscore tree dot get node, nodes in group. And then let's go ahead and quote, paste our goals. and that will give us our goals. And now I'm going to do goals instead, and I don't think there's any more goals in here. So now what we need to do is we're saying, hey, we're trying to get a simple path of this, right? But instead of doing it here, let's bring it out into our physics process. So now that we've moved this down here, what we're going to do is we're going to wrap this in an if statement. So if path dot size is smaller or equal to 0, then I want this to start running. So what we first need to do is we need to do a var rng is equal to random number generator dot new, because we're going to create a new random number generator. Then we're going to create a rng dot randomize, and we are going to say var goal number is equal to rng.randIf range. We're going to say 0, comma, goals dot size -1. So what that's going to do is that's going to give us a random goal to go after. Then what we're going to do is we'll open this up and say goal number. And that should give us back... Did I not? Oh, uppercase versus lowercase. There we go. So that should give us a random goal to go after. So let's see what happens. So you see he's running after that goal right there. He hits it. Now he's moving to another goal. It looks like it's this goal here. So he hits it, and then he's going to move to the next goal. So that's a cool way to make a kind of like a random policing character that just runs after different goals, if that makes sense. And it's random, so we don't know which goal he's going to go after until he decides to go after that goal. So that's what I have for you guys today. So to recap, what we talked about was what a navigation mesh is. We went through all the different procedures and all the different processes and options that you have that corresponds with the navigation mesh. We created a small level. We had a crash or two, and we created a small sentry-like character that runs from point to point to point. So if you guys like this video, go ahead and hit that like button. If you guys dislike this video, go ahead and hit that dislike button, because I make content for you guys, and I want to make sure that I'm making content that you guys enjoy. Now, this tutorial was a comment asking me to create this tutorial, so I do actually pay attention and create the tutorials you guys want. So thank you so much for watching. I'll see y'all next time. Thanks.